Hello everyone, welcome to Nithin Academy and I'm Nithin. I hope you all have watched my previous video on scientific endeavor because it will help you out in understanding this video to the fullest extent. Besides, I do hope you all are having a splendid time ahead. And today, in Secondary 1 Science, I'll be moving on to the next chapter, Physical Properties. And let's get straight into it, okay? Okay, so for the first segment of this video, in physical properties, I'll be going through electrical conductivity of materials. Okay, so electrical conductivity is a physical property of materials. Okay, so let's just go through it. Okay, electrical conductivity. So this red color over here is basically the definition. So let me just write that down. Okay, so let's take a look at the definition. Electrical conductivity is a measure of how easily it allows electric current to flow through it. Okay, so let me just box this up. It's a measure, okay, of how easily it allows electric current to flow through it. Okay, so this is the definition. Okay, so these two over here are basically talking about electrical conductors and electrical insulators. Okay, so let's just take a look at it. So an electrical conductor allows electric current to pass through it easily. So allows electric current to pass through it easily. Okay, so let me just box allows up. Okay, so allows, so an electrical conductor allows electric current to pass through it easily. Okay, so such materials are copper. Okay, so copper is used for wires. Okay, iron and silver. So these are just mere examples of an electrical conductor. Okay, next, an electrical insulator. Okay, so an electrical insulator does not allow electric current to pass through it easily. Okay, so what does it not allow? So it does not allow, okay, electric current to pass through it easily. So an electrical insulator, so such examples could be rubber, glass, plastic, wood, many more. Okay, so these are just mere examples, like I said. So this is basically electrical conductivity. So I hope you understood that. Now let's take a look at a semiconductor. So what are semiconductors? Okay, semiconductors such as silicon and germanium. Okay, so semiconductor meaning it conducts electricity in a semi way. Okay, so that's what it basically means. It's in the name itself. So how do we measure electrical conductivity? Okay, so how do you measure electric current basically? So we measure the amount of electric current using an ammeter. Okay, this word over here, ammeter. We've seen this word in my previous video, scientific endeavor, right? So ammeter is basically used to measure electrical conductivity. So I've already went through this in my previous video. During one of the slides, I've already mentioned that electric current is measured using an ammeter. So I hope you have remembered what I've taught you in my previous video. Okay, so this is what an ammeter looks like. Okay, so this is what an ammeter looks like. Okay, so this measures electric current. Okay, so in my previous video I've taught you all two types of data, okay, that can be collected, one being quantitative data and another being qualitative data. So between the two datas, what type of data are we collecting here? So let me just recap slightly, okay? Quantitative data means that we are using instruments to collect the data. So instruments such as the ammeter itself over here, or the ruler, and many more, okay? But while qualitative data is by using our 5 senses to take the data, okay? So over here we can clearly see that it is a quantitative data, okay? So you can see that it is a quantitative data because we are using instruments such as the ammeter, okay? So I hope you understood this part of electrical conductivity. Now let's move on, okay? Okay, so for the second segment of this video, I'll be going through thermoconductivity. So similar to electrical conductivity, but in primary school you have learned heat conductivity, right? But in secondary school we change the word heat to thermal, okay? So we are learning thermal conductivity this time, okay? So let's take a look at it, okay? So thermal conductivity. Okay, so this red color again is the definition. So let me just write that down again. Definition. Okay, so thermal conductivity is a measure of how easily it allows heat or thermal energy to flow through it. Okay, so I gotta tell you something important over here. Heat or thermal energy. So we do not use the term heat energy, okay? Okay? So when you're writing your answers in exams, please do not use the term heat energy. So do not write is a measure of how easily it allows heat energy to flow through it, okay? Because this is wrong in secondary school. In primary school, they might not have penalized you for this kind of error, but in secondary school, they do. So you should not use the word heat energy. You can use it allows heat to flow through it, or you could use it allows thermal energy to flow through it, okay? So please do avoid using heat energy. So such as like it gains this material gained heat energy, so that is wrong. It gained thermal energy is right, it gained heat is right, okay? So do not use heat energy. So that's a big no-no, right? Okay, now let's take a look at the actual meaning of it. So thermal conductivity is a measure of how easily it allows heat or thermal energy to flow through it. Okay, so I hope you understood that. Now let's move on. Okay, so these two over here, we are talking about thermal conductors and thermal insulators. Okay, so let's take a look at a thermal conductor first. So a thermal conductor actually allows thermal energy to pass through it easily. Okay, so it actually allows, okay, so this is the keyword, allows thermal energy to pass through it easily. So what are the examples of a thermal conductor? So materials such as aluminium, brass, iron, usually metals, okay? So any type of metals, so usually metals, okay? So that's what I mean. Okay, next let's take a look at thermal insulators. So what are thermal insulators? So a thermal insulator does not allow thermal energy, does not allow thermal energy to pass through it easily. Okay, so a thermal insulator does not allow. So this is the difference. Okay, while a thermal conductor allows thermal energy to pass through it easily, a thermal insulator does not allow thermal energy to pass through it easily. Okay, so I hope you understood that. Okay, so let's take a look at examples of thermal insulators. So materials such as plastic, silicone, and styrofoam, and many more. Okay, so I hope you understood that. Now let's move on. Okay, so we measure the temperature of an object after heating or cooling it using a thermometer. Okay, so we measure the temperature of an object after heating or cooling it using a thermometer. Okay, so again, what kind of data does this fall under? It falls under quantitative data, right? Because we are using instruments such as the thermometer. Okay, sorry, let me write that down properly. So you're using instruments such as the thermometer. Okay, so that is why thermal conductivity, we are gathering quantitative data and not qualitative data, which we use the 5 senses in order to collect data. Okay, so again, quantitative data. Okay, so I hope you understood this physical property of materials, basically of matter, thermal conductivity. So we can tick that off. Now let's move on to the next physical property. Okay, for the next segment of this video, the third segment basically, I'll be going through melting and boiling points. Okay, so melting and boiling points. So let's take a look at the definition of melting point first. Okay, so melting point. Okay, so what is the melting point? The melting point is basically the temperature at which a substance changes from a solid to a liquid. Or we could say that it changes state from a solid to a liquid. Okay, we could say it changes state. Okay, so the melting point is the temperature, okay, is the temperature at which a substance changes from a solid to a liquid. Okay, so melting point of water. So do you know the melting point of water is basically 0 degrees Celsius, right? 0 degrees Celsius. What about the boiling point of water? Okay, the boiling point of water is basically 100 degrees Celsius. Okay, melting point and freezing point is basically the same thing, except, okay, here we are not actually going to talk about freezing point, but let me just give you a brief summary. So freezing point. Okay, so freezing point. So what is freezing point? So freezing point is basically the temperature at which a substance changes from a liquid to a solid. Okay, so this is basically the freezing point. Okay, as you can see, it is overlapping with the boiling point, so let me just erase it. So I hope you understood the freezing point. So there's basically not much difference with the melting point. It's just the basic opposite. Okay, so I hope you understood the difference between melting and freezing point this time, because many students actually do not know the difference. They think that melting and freezing point is just the same, we can use it interchangeably. Okay, but that is wrong. Okay, so let's take a look at the definition for boiling point now. Okay, so boiling point. Okay, the boiling point is the temperature at which a substance changes from a liquid to a gas. Okay, So it's basically the temperature at which a substance changes from a liquid to a gas. Okay, you need to know one important thing right now is that pure substances boil and melt at a fixed temperature. Okay, so pure substances such as pure water melts at 0 degrees Celsius, freezes at 0 degrees Celsius, and boils at 100 degrees Celsius. Okay, and other pure substances, they have different melting and boiling points, but the thing that is common is that it boils and melts at a fixed temperature. Okay, so next, so I hope you understood this part over here. Okay, I hope you understood that. Now let's move on. Okay, we measure the temperature of a substance using a thermometer as the substance changes state. Okay, so while the substance is changing state, we measure the temperature of it. Okay, we measure the temperature of it using a thermometer. Okay, so this is basically a graph that shows melting and boiling points where exactly they are. Okay, so this part over here, melting and freezing. So like I said, melting and freezing is basically the melting point, or known as the freezing point. Okay, so it's basically when melting point is basically when it moves from solid to liquid, while freezing point is basically when it goes from liquid to solid. Okay, boiling point, the temperature at which a substance from liquid changes to a gas. Okay, and yeah, so this is basically, I hope you understood that. So boiling point is basically evaporating, and melting or freezing point is melting and freezing. It's in the name itself. Okay, so I hope you understood this diagram. It's just for more a visual look at it. Okay, so I hope you understood that. Okay, so like all of them, we take a look at what kind of data we are collecting, right? So we already know that we are collecting quantitative data because of this word here, thermometer. Okay, so this leads to quantitative. Okay, so we are collecting quantitative data because we are using instruments such as the thermometer. Okay, so I hope you understood that. Now let's move on to the next physical property. Okay, so for the next segment of this video, the fourth segment, basically I'll be going through the physical property of matter, strength. Okay, so let's take a look at it. Okay, strength. So the definition of strength. Strength refers to a material's ability, okay, a material's ability to heavy load without changing its shape permanently. Okay, so I hope you understood that. So it's this is basically something you have learned in primary school. Actually, from the beginning until now, most of it you have learned in primary school, but slight changes when it comes to secondary school. Okay, so strength refers to a material's ability to heavy load without changing its shape permanently. Okay, so this is something you have learned in primary school, and I hope you understood this. Okay, so how do we measure the weight of loads using so how do we measure the weight of loads? We use a spring balance. Okay, so this is something related to strength. Okay, so why, you may ask, is because strength over here, you can see the material's ability to heavy load, right? So these loads we need to know the weight of. So there's this there's this specific instrument we use, which is basically the spring balance. Okay, spring balance. So spring balance. So we are using an instrument here to collect the data that we need, the data of basically the weight of the loads. So what kind of data are we collecting here? We are collecting quantitative data again because of this word over here, spring balance. Okay, so I hope you understood that. So this is strength, and I hope you understood this physical property of materials. So now let's move on. Okay, so for the next physical property, I'll be going through hardness. Okay, hardness. Okay, hardness. So isn't hardness and strength the same thing? No, they are not the same thing. Okay, so let me tell you about hardness right now. Okay, hardness. So it has a pretty long definition, so take a look at it. So let's take a look at it. So the hardness of an object refers to its ability to resist scratches. Okay, so this is really important. So maybe let's highlight it in orange color. Ability to resist scratches. Okay, sorry, not orange. Okay, let me highlight it in green color so that it stands out from the rest. Okay, ability to resist scratches. Okay, next, resistance to scratches also refers to resistance to indentation. Okay, so what is indentation? Okay, you'll take a look at it later in this slide. Okay, and can be determined by measuring the permanent depth of indentation. So this over here, resist scratches, the indentation needs to be permanent in order for us to test the hardness of an object. Okay, so a hard object is able to scratch another object without being scratched itself. Okay, so what is a very hard object? We could say diamonds, right? Because diamonds literally can scratch anything, and not many materials can scratch diamond. Okay, so this is where I'm going to tell you about indentation. So a force is applied to an indenter, okay, such as a steel ball or a diamond pyramid. Okay, so diamond pyramids, like I said, diamond it resists a lot of scratches and is really hard. Okay, so diamond pyramid or a steel ball. Okay, so over here, so this indenter, so this material over here is basically a, so let's just say it's a diamond. Oh my god, sorry, it's a diamond pyramid. Okay, and the resulting size or the depth of the indentation. Okay, so let me just highlight these two parts. The resulting size or the depth of the indentation in the surface of the material is measured using a microscope. Okay, so we use a microscope in order to measure the indentation, because some of the indentation might be really small to measure, and thus we need to take a closer look at it using a microscope. Okay, here we are using the instrument microscope, right? So definitely it is a quantitative data we are collecting over here. Okay, so I hope you understood hardness. So hardness is basically the ability to resist scratches or resistance to indentation. Both are the same meaning. Okay, so I hope you understood this part, or this physical property, hardness. Now let's move on to the next one. Okay, for the next physical property of segment number 6, basically flexibility, something you have learned in primary school as well. Okay, so flexibility, so let's take a look at it. So flexibility, So this is basically the definition of flexibility. Okay, so let's take a look at it. The flexibility of an object refers to its ability to bend without breaking. It also can return to its original shape and size after bending. Okay, so let's take a look and let's highlight the important stuff. Okay, the flexibility of an object refers to its ability to bend without breaking. It can also return to its original shape and size after bending. Okay, original shape and size. So basically is the ability to bend without breaking. Okay, next. So how do we take a look at flexibility? Okay, so we perform a visual check to see if the object is able to return back to its original shape and size. Okay, so a visual check. Okay, so this is basically an example of flexibility being tested. So the person is bending a ruler, okay, and after this the ruler will return to its original shape and size, basically being straight and not bent. Okay, so we are taking a visual check. We are performing a visual check on this. What does this mean? We are collecting a different type of data, not quantitative data. We are collecting qualitative data, right? Qualitative data. So this time we are collecting qualitative data because we are performing a visual check, meaning that we are using our eyes to see. Okay, we are using our eyes to see. So basically falling under the category of sight, one of the 5 senses. Okay, so let me just write down 5 senses. Okay, so we are performing we are collecting qualitative data basically for flexibility. So flexibility, I hope you understood that. So this the physical property of flexibility. Now let's move on to the next physical property. Okay, so for the next physical property at the next segment 7, I'll be going through density. Okay, density is something really important in secondary school. Okay, so please do listen closely to this. So density. Okay, so let's take a look at density. So density over here. So let's take a look at the definition of density. So the density of an object is defined as its mass per unit volume. Okay, now I'll tell you why. Okay, this refers to the amount of matter an object has in proportion to its volume. Okay, so amount of matter an object has in proportion to its volume. Okay, next, so we need to measure 2 things when we are taking a look at density. We need to know mass and volume. Do you know why? Because of this thing called the density triangle over here. Okay, so please do take a look at this. So we represent density using this symbol. Okay, it looks like a P. Okay, so we use that symbol to represent density. So this triangle, just like the DST triangle you have learned in speed. Okay, the DST triangle you have learned in speed. So basically the DST triangle is basically distance, speed and time, right? But for density, it's mass, density and volume. So basically density is equal to mass over volume, right? So that's what they meant by density of an object is defined as mass per unit volume. Okay, mass per unit volume. So this means mass per unit volume, basically meaning mass over volume. Okay, so let me just write down all the possibilities over here. So density is equal to mass divided by volume. Mass is equal to density times volume, so P times V, and volume is equal to mass divided by density. Okay, so these are the three possible scenarios in order to find each of the letters. Okay, so how do we find mass? First of all, we use a beam balance or an electronic balance to measure mass. Okay, beam balance or an electronic balance, okay, to measure mass. So depending on the object, we use different instruments. So depending on the object, we use different instruments to measure volume. So if you want to measure the volume of a liquid like water, we want to use a beaker, a measuring cylinder, many objects like that. Okay, so I'll go more in depth later. Okay, so what kind of data are we collecting here? We are collecting quantitative data. Okay, so we are collecting quantitative data because we are using instruments for volume and for mass. Okay, now let's move on. Okay, so still in density, now let's take a look at the principle of flotation. Okay, so same diagram again. So less dense objects float, okay, while denser objects sinks. Okay, in some of the primary schools, you might have learned this principle of flotations, such as in my primary school, I've learned this already. So less dense objects float and denser objects sinks. Okay, so let me show you a scenario over here. Okay, let's take a look at which, so let's arrange, let's take a look at which is least dense and which is the most dense and which is in between them. Okay, so less dense objects float, right? So float meaning it must be above the water, okay, and not suspend in the water like this one. Okay, so another thing you need to know, if the density of the object and the liquid that they are floating that they are submerged in, right? So example for this B over here, the density of this jar and water is basically the same. Okay, while for A is floating, right? It's not fully submerged. Some of it is we can see it from the top. So basically this is least dense. Okay, least dense, and it is less dense than water. Okay, let me write that down. Less dense than water. And for C, it's fully submerged and it's sunk. Okay, so basically it is more dense than water. And it is most dense. Okay, so again, how do we measure mass and volume? So we use a beam balance, electronic balance to measure mass. We use different instruments to measure volume. Okay, so how can this be applied to this diagram over here? So density is equal to mass over volume. So in order to find the density of an object, such as these materials over here, okay, of an object, we need to know its mass and its volume in order to find the density of it. Okay, so I hope you understood that. Now let's move on. Okay, next, still under the chapter of density, we're going to take at how we measure regular solids volume, irregular solids volume, and how we measure liquids volume. Okay, so how to find volume basically. So regular solids, so we use a formula depending on the shape of the object. Okay, so depending on the shape of the object, we use formulas. Okay, So if it's a cube, we use the formula, you know it, right? Length times base times height. If it's a rectangular prism, so all of these formulas, right, you will learn in secondary school during maths lessons, and some of them during science lessons. Okay, but you won't learn the formula for sphere. Okay, in exams, right, sometimes they ask this type of question. They might say find the volume of this object, and then they will give you the formula to find the volume of that object, and then with the given information you will learn to use that formula and find the volume of that given object. Okay, so yeah, so you need to know some of these formulas, such as and sometimes you need to know the basic formulas that you're learning in secondary 1 math, such as the cube, rectangular prism, right square pyramid, the cylinder, the triangular prism, cone, and many more. Okay, so that's for regular solids. And for irregular solids, what we do, okay, so this is basically a measuring cylinder. Okay, so an irregular solid could be like a rock. We want to measure the volume of a rock. So first we have filled up the measuring cylinder to 20 ml, right? And when we put the rock in, the reading became from 20 ml to 40 ml. So what we do is take 40 ml, 40 minus 20, we get 20 ml. So the rock is basically 20 ml. Okay, so the rock's volume is basically 20 ml. Okay, and for slightly and another way to measure the volume of an irregular object is that we first by using a displacement can. Okay, so displacement can, you will do this experiment in secondary school during your lab sessions. Okay, so using a displacement can, so how do we use it? So first we fill the displacement can to the brim. Okay, the brim meaning right before the hole. Okay, so we do not fill it over the hole. If not, the water will come and land in the measuring cylinder. Okay, so fill it to the brim right before the hole. Okay, next, lower the object into the displacement can. So over here is a solid lump, so we lower the solid lump into the displacement can. Next, the water displaced is the volume of the object. So the water displaced, right, in the measuring cylinder over here is basically the volume of the object. Okay, so this for displacement can. Okay, so I hope you understood that. Next, how do we measure the volume of liquids? So depending on the amount of liquids measured, different types of instruments should be used. Okay, so these are the different types of instruments, like measuring cylinder, syringe, and yeah, many more. Okay, and all of this you will learn in secondary school science as well. Okay, next. Okay, so this is quite important. So how do we measure solids which do not sink? Okay, so how do we measure volume of solids which do not sink? So over here we are finding volume. Okay, so there are 8 steps we need to follow. Okay, firstly, we need to fill the displacement can to the brim. Okay, take note, we are still using the displacement can. Okay, okay, so displacement can, so we are using the displacement can. So firstly we need to fill the displacement can to the brim, like I explained in the previous slide. Next, we lower a sinker. So sinker is basically an object that sinks. Okay, so basically metal bulb. Okay, so firstly we want to find the volume of the sinker. Okay, so metal bulb into the displacement can. So what we are trying to do here in the second step is to actually find the volume of the sinker. So then we can minus off the volume of the actual object and the sinker in order to find the volume of the actual object. So you'll see that in the following steps. Okay, next step. Okay, so for the next step, the water displaced is the volume of the sinker. Okay, so like I said, the water displaced is the volume of the sinker. Next, we need to repeat step 1. We fill the displacement can to the brim. Okay, we tie the sinker to the object, we lower the sinker and the object into the displacement can. So 7th step, the water displaced is the volume of the sinker and the object. So what we do, we take that volume minus the sinker's volume in order to find the object's volume. Okay, so subtract the volume of the sinker from the volume in step 7, meaning the sinker and object. Okay, the sinker from step 7, sinker and object, to find the volume of the actual object. Okay, so I hope you understood that. So this is something important. They might ask you this type of question in examination, and for practical exams. So in secondary 1 science, there's also practical examinations, basically doing experiments and writing down. They might, so for practical exams, right, they will ask you a question in your examination booklet. So that question you have to answer by doing an experiment in the lab. Okay, so you do the experiment and your answer. Okay, so how you answer is basically by telling them what you actually did, and this is one of the model answers we are looking for, when the teachers are looking for when they are marking. Okay, so please do take note of that. Now let's move on. Okay, so for the 8th segment of this video, I'll be going through the vernier caliper. Okay, the vernier caliper. So you need to know this. We are learning this right now, vernier caliper. So what is the vernier caliper? So this is what the vernier caliper looks like. So the vernier caliper has many parts. Okay, so these two over here are actually the external jaws. Okay, these two over here, these two jaws over here are actually the internal jaws. This scale over here is called the vernier scale. Okay, vernier scale. This bigger scale over here is actually called the main scale, and this extension over here is basically the depth measuring probe. Okay, so these are basically the parts of the vernier caliper. Okay, so I need to know the parts. Okay, they might ask this in exams. Okay, next. Okay, so for the vernier caliper is more precise than a ruler. Okay, so a ruler gives readings to 1 decimal place in cm, while a vernier caliper gives readings to 2 decimal places in cm. Okay, so in this slide I'll actually only be going through the parts and some of the meanings of the parts. Okay, so external jaws. So what are the external jaws used for? So they are used for finding the external diameter of objects. Okay, so as you can see over here, the screw, they are measuring the external diameter of the screw. You can measure external diameter of a beaker, a test tube, a boiling tube. Okay, many more. Measuring cylinder. And then internal jaws are used for internal diameter of objects. So internal diameter of test tube, boiling tube, measuring cylinder, and many more. Okay, so the depth measuring probe is basically to measure the internal depth of a test tube, boiling tube, or any other thing that you can measure. Okay, so let me just draw a test tube for you. Okay, so this test tube, so this part over here actually goes in over here in order to measure the depth. The external jaws will clamp on to the external part to measure the external diameter, while the internal jaws will clamp on inside in order to measure the internal diameter of the objects. Okay, So I hope you understood that. Now let's move on. Okay, so still in the vernier caliper, let's take a look at how to read the vernier caliper. Okay, so let's take a look at how to read the vernier caliper. So these are the steps. Okay, so assuming that this two parts are actually already clamped, and the external jaws are already clamped onto something. Okay, let's so we need to focus on two things: main scale and vernier scale. Okay, so these are the only two things that we are looking forward to when we are reading the vernier caliper. Okay, reading the vernier caliper is actually really simple. Okay, so let me just tell you in two simple steps. Okay, so first step. Okay, first of all, the vernier caliper is in two decimal places, right? So first point, so the first decimal place and the first whole number is basically the main scale, and the second decimal place is the vernier scale. Okay, so the first step, the zero of the vernier scale, is between 3.3 and 3.4. Okay, 3.3 and 3.4. Okay, so the reading starts as 3.3. Okay, why is this so? Okay, if the line is exactly on 3.3, right, we start as 3.3, and then next the next decimal place we need to find out. Okay, but if it's on 3.4, right, we start the reading as 3.4, but it's in between this case. So where do we start, 3.3 or 3.4? We start from 3.3. Okay, because it is not touching the 3.4 line. Okay, so that's why we need to start at 3.3. So as long as it is not right onto the 3.4 line, perpendicular to it, we start as 3.3. okay, in this case. Okay, in other cases as well. Okay, so this is just the scenario that I'm telling you. Next, so we've already found two of the places that we need to fill. The last place, vernier scale. So this is slightly harder. You need to use your visual skills. Okay, so next, look out for where the main scale and vernier scale intersect. So it intercepts over here. Okay, on that line. So the markings appear straight. So the markings needs to be appearing straight. So really straight. It can't be like this over here. It can be looking straight, but sometimes it's actually not straight, like very hard to see. Okay, so from where it intercepts, right, so on the vernier scale we actually need to count. So 0, 1, 2, 3 and 4. So the line intercepts on 4. So 4 is basically the number that we are supposed to write in the second decimal place, because the vernier scale is basically 0 to 10, right, is basically 0.01, 0.02, 0.03, 0.04. So that's why we got this 0.04. Okay, so that's why this 4 came down here, because here is already 3.3. Understood? Okay, now that you have learned how to read the vernier caliper, try out this. Okay, so pause the video and try out this question. So try this on your own. Okay, so pause the video and try this. Okay, so I think I've given you enough time to pause this video and try this on your own. Let's go through the answer right now. Okay, so how do we do this? So first step, the 0 of the vernier scale is between 3.3 and 3.4. So where is the 0 over here? Oh, the 0 is exactly on 2.1. Okay, and another thing we can see. Okay, do you remember the second step? The markings appear as straight, right, where it intercepts. So not only does the 0 is exactly on 2.1, it is also completely straight. Okay, completely straight on it. So actually we do not even need to do anything. So it's basically 2.10. So this is the reading. Okay, many students make mistakes in this type of scenarios. Okay, when it's 2.10, right, the students actually write it as 2.1 because it means the same thing, right? But why we need to write 2.10 cm is because that vernier caliper reads up to 2 decimal places. Okay, so that is why we need to mention the 0 over there. If not, they would think that you have actually measured the reading with just a ruler, because rulers only measure up to 1 decimal place. So that is why there's the need of telling that we are measuring to 2 decimal places and writing as 2.10 cm. Okay, so if you do not write 2.10 cm and you write 2.1 cm in the exams for such a question like this, the markers will actually penalize you marks. Okay, so for this slide, I hope you have learned how to read the vernier caliper, and with that I come to the end of the video. Okay, thank you for watching everyone. I hope you have enjoyed this video and understood more about secondary 1 science, the second topic of physical properties. And I hope this really helps you. And if you're not subscribed to Nithin Academy, please do subscribe. I'll see you again in my next video. Bye.